Good morning or afternoon, depending on where you may be joining from today, and welcome to the PGEdge webinar, Logical Replication Features in PostgreSQL 16. My name is Kathleen Tassa. I'm a member of the PGEdge marketing team, and I will be your moderator for today's webinar. Our speaker today is Database Evangelist and PGEdge's Director of Services and Support, Hassan Hadi. And we also have our two co-founders joining us today, CEO Philip Merrick and CTO Dennis Lucier. Both will be participating in the Q&A portion of this webinar. So just a layout of how this webinar will go. Hassan will present for about 30 to 45 minutes, and then we will have about 15 minutes in Q&A at the end. Please feel free to ask your questions throughout the webinar in the Q&A box listed at the bottom of your screen. We will do our best to get to all of them. Don't worry if we don't get to your question, as we will be sure to follow up post-event. So without further ado, I will hand it over to Hassan Hadi.
Thank you, Kathleen, and thank you everyone for attending this webinar. This webinar is about Postgres replication and primarily about the improvements of logical replication improvements that went into Postgres 16. So that's me. My name is Hassan Hadi. I am Director of Support and Services at PGEdge. PGEdge provides distributed PostgreSQL with active capabilities supported on multi-cloud or on in-house development. It's based on 100% PostgreSQL, and it provides distributed cluster, for the optimized for the network edge, which provides ultra high availability and reduced data latency, and also addresses the requirements for data residency and ultra high availability. So I worked with databases for more than 20 years, Oracle, PostgreSQL, SQL Server, but primarily for the last 15 years, I've been working with PostgreSQL. I'm also the proud owner of 3 PostgreSQL contribution coins for the last 3 releases of PostgreSQL. I've just put one there. In the Postgres community, I've been, basically contributing at multiple levels, but it's mostly been around, patch reviews, patch testing, and technical blogs, and presenting at conference, etc. In here, I've also listed some of the previous companies that I've worked on. So in the agenda today, we are going to basically talk about replication in general and talk about different replication methods, and then we are going to dive in to our main topic, which is the improvements that went into Postgres 16 for logical replication. Then it will be followed by a small short demo, live demo of some of the key features that were part of Postgres 16, and then we are going to follow that with some of the results of basically executing, showing those features. So this slide is basically pretty basic. This is about replication. So at a pretty basic level, replication is about copying data between 2 systems, right? So when you talk about databases, replication is about copying data from one database server to another database server. And when we are talking about database replication, we need to make sure that it is meeting the ACID properties, right? So this diagram here basically shows a simple form of replication, which is the one-way replication where the data is being replicated from one primary to multiple secondaries. So that's kind of a brief introduction to replication. Then we have the use cases here. So these are actually some of the general use cases of replication. They're not actually listed according to the various replication methods or types that we have available in PostgreSQL. So high availability is like on the top of it, which is kind of a very key requirement right now from replication. And high availability basically means that the application continues to run seamlessly, in case without interruption in case of a node failure. So that's one of the top requirements for replication. That's followed by data latency, which is also really important. Data latency is basically the data response time, right? So, with the active multi-master replication that I'm going to talk about later, you can actually have the data deployed close to the user, which means that you get a better data latency. Then data residency is also another key use case there, which means that you can actually, fulfill all the legal requirements of having the data, keeping the data at home, or, in particular cases, keeping data in a particular geographical location. So then you have near zero downtime for major upgrades across version. That's also have become a really key use case of replication. And basically what that means is that if you've got, if you are, if you are running several, primary and secondary nodes, then, you can actually, in case of, you can actually upgrade one of the nodes by bringing one of the nodes down, and the rest of the cluster can continue to run without any problem. So, logical replication, which we are going to talk about later, basically offers that, offers that functionality where you can actually have replication across versions. So the next one is load balancing and query routing. That's also another really important one. And that's basically when you can actually have your load distributed between write and read replicas. So you actually send all your traffic, write traffic to the primary nodes, and you can actually have the read queries distributed on the secondary node. So that's also an important one. Replicating between different major versions of PostgreSQL. Of course, that's another logical application use case. Then being able to give access to a group of users for a subset of data, that's also another important one. And then we have data migration, ETL, and data warehousing also as important use cases for replication. So this is one of the popular methods of replication. That's asynchronous replication here. And basically, as you can see from the diagram, in case of replication, the data only gets committed. Data gets committed on the primary node without waiting to actually without waiting to actually get the acknowledgement from from the secondary nodes. So as you can see on the diagram here, you basically, the clients does the transaction and it gets committed on the primary without having to get the acknowledgement from the from the secondary node. So that's one of the important methods of replication that's been widely used as asynchronous replication. And then we have the synchronous replication here, which is again a widely used method of replication. And in this case, as you can see on the diagram here, that you basically send your you basically you get the transaction, and the transaction only commits once it is committed on all the secondary nodes, right? So as you can see here that we actually start the transaction, and then it basically does the write on primary, and then you basically you wait for the transactions to complete on the secondary nodes before the transaction completes. But with this, you also see this blue dotted line here, which is a quorum commit feature that was introduced in PostgreSQL 10.0. And basically what that does is that you're on in case with synchronous replication, it can actually be it can be very expensive if you are running with the large number of secondary nodes, right? So in terms of PostgreSQL come up with a feature called quorum commit, which actually allows you to actually commit the transaction on the primary once it's finished on a desired number of on secondary nodes. So in this case, if we have two replicas, and we say that we can do the commit on the primary once it's commit on one replica, then you can basically use the quorum commit feature in this case. So this is the quorum commit feature. And in case of synchronous replication, if you don't use the quorum commit, then the transaction will only complete once it's acknowledged from all the replica nodes. So now we are diving into basically the various methods of replication that are available in PostgreSQL. So obviously this streaming replication, physical replication is basically one of the standard method of replication in PostgreSQL that is very popular. And this is also called the log shipping method of replication, where basically you have you're constantly shipping the wall records to to number of standby servers. It can be one or more standby servers. Streaming replication was added in PostgreSQL in 9.0. And you basically have your wall logs generated on the primary, and they are periodically shipped to the standby nodes. One thing to note here that this type of replication is only possible if you are basically, if you have the same version of PostgreSQL, running on both primary and secondary nodes. So the diagram below shows just a basic setup where you actually have a primary node and a secondary node, the wall sender, using the archive command. It is basically constantly shipping the wall records, using the wall sender process. On the secondary, we have the wall receiver that's basically, receiving the wall file. So this is one primary and one secondary, but as I said earlier, you can actually have, more than one secondaries and to a primary. And in most cases, the walls, which is a 16 megabyte size, is actually archived to an external disk. So this actually brings us to one of the most recent but very evolving and a very popular method of logical application that has actually evolved in the last several years and is actually getting more mature now. So logical replication is actually a method of copying data objects and changes based on the replication identity. So replication identity was basically a table level parameter that was introduced in PostgreSQL 9.4, and basically what that does is that decides how much what information is written actually to the wall files. In case of logical application, we actually have more control and more, it's more fine-grained control, because you are actually, you are actually picking the objects that you want to replicate. So this offers a very fine-grained control over data replication and security. So this is the typical publisher and subscriber model. So you can have one or more subscribers that subscribe to one or more publishers. This has kind of a similar architecture underneath as to with streaming replication or physical replication, where you actually have the wall sender process, and it basically makes use of the logical decoding plugin, which was added to PostgreSQL, and basically what that does is actually copies data in a format that is interpreted by other systems. So with logical replication, it's possible to actually, to replicate, from your Postgres databases to even, other systems, right? Because the data is, using the logical decoding plugin, the data is actually copied in a format that can be interpreted by other systems. So publication is typically, a table, or it can be a set of tables, and obviously subscription is a kind of the downstream of the logical replication. So that's briefly about logical replication. Then I want to talk just briefly about the two deployment models of replication that we have available. So active standby is the one that we talked about in case of streaming and physical application, where you have one primary and one or more standby servers. Obviously, you have the write traffic, going to the primary server, and the read traffic is actually load balanced on the read replicas. But obviously, this is not something that works out of the box. You need to actually use external tools in order to support that. In this mode of deployment model of replication, you can have the synchronous or asynchronous or the quorum commit choices. I've talked briefly about all three of these previously, and the use cases are high availability and load balancing. You have automatic failover in case of active standby, where actually if your primary node goes down, then you can actually promote one of the secondary nodes to be the primary. But again, this is something that is possible using external tooling. So with this, obviously you get a very low chance of data loss. The other one is active deployment, which is also very popular one, and I've got Spock next to it. Spock actually is an extension that is owned by, that's released by PG Edge, and that basically provides the multi-active replication between PostgreSQL servers. So in case of active replication, you have one or more primary servers that are replicating between each other. This is not something that's part of PostgreSQL core yet, Obviously, it's something that's provided by third-party tools and extensions, and Spock is one of the one that I just talked about. Obviously, when you have active replication between two servers, you need to take care of things like conflict detection and conflict resolution. So that's something that is obviously not part of the PostgreSQL core, and it's provided by the third-party tools and extensions. The use cases for active is obviously ultra high availability. That's one of the key feature that PG provides. Again, data latency and data residency are the top use cases of active replication. And obviously near zero downtime upgrade is also a critical one there. So I've listed like the top 4 use cases of active replication there. I'm sure there are others. So just quickly on this slide, in this slide, I basically tried to show the evolution of logical replication in retrospect. So it was added in Postgres 10, with Postgres 11 coming in with the reduction on memory usage for logical decoding, truncate replication, then Postgres 12 allowing copying of replication slots. Then interesting features were added in 13 and 14 with the support for streaming in progress transactions, binary data transfer, and then in 15 you have publications for all table and schema and replication of prepared transactions. So obviously this requires a lot more time. So this is just to kind of show you how it evolved over the last several years and several Postgres releases. Now we're going to dive in to our main topic, which is the enhancement that were added for logical replication in Postgres 16. So my topic would be parallel apply. So this is basically where you can actually use multiple background workers in parallel on the subscription side to basically apply the changes, right? So prior to this feature, obviously the changes needed to be changes are streamed. The subscriber pulls the changes from the publisher, and they are basically applied using a single process. But with this feature in place, you can actually now use multiple background workers, and you can actually apply the changes in parallel. So this is a performance feature, and the syntax is here. Basically, you create your subscription, and for streaming, you have to set it to parallel, right? So streaming is either parallel or off or on. So the parallel support was added in Postgres 16. This is obviously a performance feature, as we discussed, using parallel background workers for applying changes at the subscriber node. The parameter that you need to use in order to select the number of workers you want is max parallel apply workers per subscription. In the tests that I have done that I'm going to try to show you, I'm seeing up to 50%. I've listed 30 to 40, but I'm seeing kind of up to 50% performance gain. But obviously that's going to vary based on your setup. Obviously, this is only for in progress large transactions. So this feature will only give you performance for large transactions, and it will basically so I'll show you that, show you how this works at the demo. The second feature that I want to talk about is origin filtering. This is kind of a start of bidirectional replication. It's obviously not the complete thing, it's just the beginning. The syntax, as you can see there, is obviously you create your subscription, and in the origin, you have to basically set it to none. Right now, with Postgres 16, you can set the origin to none or any. Any is obviously the default. And when you set it to any, that basically means the subscription will send changes regardless of the origin, right? And basically what that does is, if you've got a bidirectional replication set up where you have, both publisher and subscriber are also the subscriber or publisher to each other, you can actually run into infinite loops. Or if your table has primary keys, then when basically if a publisher sends a change to subscriber and subscriber sends the same change back to the publisher, that will lead to index violation and errors or infinite loops. So Postgres 16 basically added the support for origin none, And basically that enables subscriber to request publisher for changes that don't have an origin, right? So obviously this makes, as a start of the bidirectional application between the two servers, but we need to make sure that, both servers and publisher, they need to be in Postgres 16, and, both servers will be publisher and subscriber to each other. So again, I'll show you, some of the results, for this feature. The third feature that I want to talk about is allow logical decoding on the standby. So this feature is also something that's been worked in the community for some time. And with this feature in Postgres 16, we are now able to actually create replication slots and basically do logical decoding from the standby server. So, this feature has been working in the community for some time. And, this feature actually makes it possible for users to actually create a subscription against a standby server. Prior to at a standby, you get error, logical decoding cannot be used while in recovery. And, so basically, trying to create a subscription against the standby would actually result into this error. So obviously what that does is it actually reduces the load on your primary server. So, you can actually use the standby for some subscribers. So, instead of basically subscriber pulling data from the primary node, it basically pulls the data from the standby node. So that's also a really good feature in Postgres 16. Then this is also an interesting performance feature, copy data in binary format. Basically what that does is, you can actually create your subscription and you can set binary equals to true, right? So what that does is it actually does the initial copy of the data, in binary format. So prior to this feature, if you basically, prior to this feature, if you have a large table, right, that you just subscribe to, and you try to copy that table, it's not going to copy that in the binary format, and that will take a lot of time. So this enables logical replication to copy databases in binary format. And with this feature now, initial copy for the tables will be done in binary format. And this also gives a really good performance increase in case of large size tables with binary columns. The test that I ran as a purposes of demo, I got a good just over 30% increase for a 5 GB table that I tried to copy initially with binary turn to true and turn to off. So, so there was a good performance there, but also in this case, you need to make sure that both publisher and subscriber are running Postgres 16. This is another feature that we've added in Postgres 16, basically replica identity. I talked about earlier. This is a new table level parameter that was added in Postgres 9.4. And basically that, using that parameter decides how much information is written to the wall. Possible values are full using index or index name, nothing or default. So one thing to note here is that replica identity can only be changed with an alter command, right? So prior to this feature, tables that are set with replica identity full will actually result into a full table scan at the subscriber when a change occurs, right? In case when there is no replica identity or primary key index is not available. With this feature in place, you can now actually create a B tree index on the subscriber with at least one column reference to avoid full table scan on a subscriber, right? So with this feature in place, if you have a B tree index on the subscriber and you don't have a replica identity and you don't have a primary key index, then instead of doing a full table scan the subscriber in case of a gene, it's going to basically do an index scan, using the index, the B tree index that you have created on the subscriber. So that's another performance feature. And this is something that obviously currently it's only support B tree index and no partial index, but I think the community is working on changing that in future. So just looking at how much time. Okay. So in the next part of this presentation, I'm going to try to, obviously I won't be able to run all the features, but I'm going to try to run one of the features, and then I'm going to show you the results for the various tests that I've done. So I'm gonna go back here, and I've actually got two nodes that I've set up here in the cloud. One node is actually the publisher node, which is running in US East 2. And the other node, which is a subscriber node, is actually running in US West 2, so kind of across the country. So it's all set up here. And so I go in here and I basically just run my publisher script, and basically goes in and does the creates a table in the database, creates a publication. Then I come here and then I basically set up the subscriber, and in here I basically say run it with parallel, right? So I can get it to run with on or with the off or in parallel. So in here I'm going to say run it with parallel. That basically goes in, and then it's going to create a bunch of subscriptions there. Ignore the errors there. The errors are just something that didn't exist, so it was part of the script. So it basically goes in and creates the subscription there, and then I go back to the publisher, and then I run the test. So this test is going to start running, but in the meantime, I'm going to show you the results of this test and some of the other tests that I've done. Okay. So with the parallel apply test that I just performed in the background, I configured it with about 4 parallel apply workers using the parameter that I talked about earlier. Obviously, I turned the initial copy to off because I want to actually copy, I want to copy all the data that was inserted in the table. So for this purpose of this test, I actually I'm replicating a large transaction with about 5 million writes into a publication table. Obviously, subscriber is added to the standby node just to make sure that it doesn't come back immediately. And then I'm actually measuring based on the transaction time. So the time it takes to actually complete the transaction of writing 5 million in records in the table, right? So the results that I got back, and this is this was the script that I ran, which actually inserted those records. And as you can see here, with parallel streaming set to parallel, I got about, the script took about 58 seconds, and with streaming set to off, it took about 1 minute 46 seconds. So I kind of got up to 50-60% performance gain, for large in progress transaction with parallel apply. So that was that's the parallel apply. The origin filtering feature that I also have a script for, and if somebody wants to actually see the scripts or want me to run the scripts, I can definitely do it offline. So in the publisher, I basically go ahead and create one of the tables is the primary key here, as you can see. Then I create the publication on the subscriber side. I also create that table. Then I create the publication. So as you can see here, I'm creating publication here, and I'm also creating a publication on the subscriber as well. And then in the subscriber, I'm basically subscribing to the publication that was created on publisher. And in the publisher, I'm creating another subscription that is actually subscribing to the publication that I created in the subscriber window here. So basically both publisher and subscriber to each other, right, on the start of bidirectional replication. So in case when you try to insert any records on the publisher side, and if you go and scan the log files, you'll basically see this error here, right? Because we had a primary key, and in this case the origin was set to any, right, which is the default, which basically meant that it's basically sending the data to the publisher without considering the origin. So in this case, the same record was sent back and it resulted in an error. So what you need to do in order to get rid of this error or get rid of infinite loops, you need to basically alter the subscription, right? So in this case, we went back and this subscription that we created on the publisher, we basically set that to none, right? And by doing that, it started doing the origin filtering, and then you won't run into these errors if you have a primary key or infinite loop. So this was the origin filtering feature. Then the binary copy feature. So this was basically the binary copy where actually it does the initial data copy in binary format. So in here, you can see I created a table here with a couple of byte A columns, and then you basically set up the publication for that table. Then I did a really big insert. This is into this table that created around 5 GB table size, right? So on the subscriber, and then I created that subscriber, and then I created the subscription. And in here, you can see I'm turning copy data to on, which basically means that I want this to basically do the initial copy, and I'm setting the binary to true, right? So I want this, I want the initial copy to be done in binary format, and and I also added a function on the subscriber, which basically what that does is actually waits for initial copy to complete, so I can actually time it and see how much time it's going to take, when we set binary to true or set binary to false, right? So copying across about 5 GB of data. So basically, this is the results that I got for the test that I've done. Again, I have the script, so if anybody wants to see it, we can do that. So with binary copy set to true, actually, I got this other way around. So when binary copy is actually set to false, it took around 6 minutes 23 seconds, and when binary copy is set to true, it took around 4 minutes 27 seconds. Sorry, I got that other way around. So that actually got me a performance up to 32% performance gains in performing initial table copy in binary format. When you basically compare binary format versus non-binary. So this is a pretty good performance gain with this new feature in Postgres 16. So that kind of brings me towards the end of the presentation. I think there are some questions there.
I believe most of the questions were answered during the presentation. Does anybody else have any questions? Please put them in the Q&A.
Am I allowed to ask a question?
I'm gonna allow you to talk and ask your question. Hold on one second. Okay.
Hello.
Can you ask your question?
Yeah, hi. Hi, Hassan. Very
Hello.
nice. Yeah. Actually, I have a doubt, Hassan, in the logical replication. Consider that we have set up a logical replication, and we took the snapshot. Means the replication is running fine, replicating all the data. And the thing is, we took the snapshots and we restored it into a new separate set of instances as a publisher, new publisher and subscriber. But in the subscriber end, I am able to see the subscription state is enabled and active. But in the publisher end, the replication slot initially disappears, but later it comes and says that the replication slot is false, active is false. So can we enable or do some, is there some mechanism either through origin advance to bring back the replication and resume it without dropping the subscription?
I haven't actually tried that case, but I guess with this origin filtering column, I think we can definitely see if there's a way to bring it back.
Yeah. Hey, Essen?
Yes, Dennis.
Yeah. So as I understand that, there's a couple of hoops you have to jump through. So in the PG Edge stuff that we're doing, you got to kind of manage those slots separately. So when just because you made a replica, there's nothing that says that automatically you want that to join the cluster as a physical streaming replica. So there's nothing that happens automatically there in Postgres, but there are ways that you can control that through the various APIs. So if you're doing that situation, there's some more follow-up work you're gonna have to do at the API level to activate or deactivate certain things, or to join it either as synchronously or as an asynchronous replica, right? Postgres itself won't try to guess what you're going to do next. You're going to have to tell it and do some manual work there in the open source stuff. And even in vendors' proprietary solutions like ours, there's active work going on in that area to make it to make you be able to tell what you're looking for to happen and to make that happen without you having to do manual steps. If that helps. If not, we can take that offline.
Yeah, definitely.
Is there a follow-up to that question? Any other questions? You could either raise your hand or put it in the Q&A. Okay, there's a question in the Q&A that reads, what will happen if we need to be added, if we need to add an additional column?
So you're basically trying to add additional columns to the publication.
Well, I could take that, Essen. So what happens is in general, what we recommend is this is kind of something that happens with our Spark. So you can do it when you're going to add a column, you could do your own trigger that automatically adds that column and does whatever. But we really, on a personal level, we have, like in our Spark solution, when you add a column, there's a replicate DDL command. So my personal recommendations is when you're going to replicate DDL, do it very deliberately and consistently. So if you're doing, if you're doing logical replication, add the column, add it to both of them, make it a nullable column, and then add that to the replication set. So you can do it with triggers and stuff like that, but I usually, as you start looking at Spark or PG Logical, there's a replicate DDL command that will help you do it in both places. And I always recommend people to use commands like that, because you don't, if you're starting to do logical replication, you really do want to keep, both tables in sync. And you, of course, if you're doing it on purpose, you can only replicate a subset of the columns and stuff like that. So you have a lot of flexibility, but I recommend you use some of the extensions, the open source extensions like Spark or like PG Logical, to replicate your DDL specifically.
Yeah, and then
He's adding a column. Here's
Yep.
what he asked, I believe.
Yeah, no, I was just reiterating what you said, that in the Spark extension, open source extension from PG Edge, we actually have the capability to actually do the schema replication, DDL replication.
Yeah, so we don't in Spark specifically, we want you to do replicate DDL, so that it's as simple as calling the replicate DDL CLI or API, having it make the replication change in a coordinated way across the nodes and doing that. So that's the way we recommend that you do it. We don't actually, at our personal level, we believe in our working on a setting to say block automatic DDL changes if you're on tables that you're replicating live, and so that you're explicitly doing them thoughtfully. So there's different philosophies on that. At PG Edge, in the short run, we're definitely not trying to automate all DDL, because sometimes you're doing it in such a way that we would rather have you explicitly do the DDL change and then make sure we can coordinate between the nodes to do that. So there are some proprietary solutions that will try to do automatic DDL. Our PG Edge stuff is not proprietary, and we don't try to do it automatically. We want you to ask for it specifically, and then we will handle the details.
I think that answered the next question, that PG Edge automatically replicates the DDL as well.
Yeah, it can do it for you if you call explicitly the replicate DDL command. So tell it that you want it to replicate the DDL, and it will. It just wants you to be explicit about it, and we think that's a better, simpler, safer way to do it.
Okay. Thank you. Any other questions? You can either raise your hand or put it in the Q&A. No, one more. Okay. Partitioning handled automatically, question mark.
Yeah, so Postgres logical replication does handle partitions. So that's, so that's supported.
Great. Any other questions? Still have a couple minutes.
So, Essen, to clarify, you're saying that all you have to do in the, right, all you have to do is add the partitioned master table and automatically partition the replicas?
Yeah, but so I believe it doesn't actually do the partition route. So but partition table replication is supported. Yeah.
Yeah.
There's another question. How about the multi, oh,
Cool.
sorry.
Yeah, and there's some, no, go ahead, Catherine. Fine.
How about the multi-master replication in native Postgres could we expect?
Yeah, so that our active conflict resolution, what our philosophy is at PG Edge is that we are making as few changes to the Postgres core as possible to enable more and more features, including multi-master and conflict resolution. So the Postgres core is continually adding features so that you can do more and more things. You don't have to do them in a separate extension. Our extension is community licensed. I think that the core community is going in this direction, but they will so I'm saying most core features don't involve like coordination across distributed nodes, right? They may enable that, but the actual coordination of it is usually with third-party open source and or community licensed or even proprietary extensions. So the community is heading towards supporting more and more robust features and logical replication natively and in parallel, et cetera. But the enhanced the enhanced conflict resolution are still in extensions that are outside of the core. And we'll see in PG 17, 18, however, we'll see some of the more basic features may be added. I do not know that yet.
That's right. Yeah.
Okay, we have one more question. Is the partitioning multi-master two-way replication using PG Edge?
Yes, you can do multi-master on partition tables. I know one of the things that that Jan, who's my lead developer, is working on in PG Edge. So this is a PG Edge specific question. So multi-master, yes, on partition tables. We're also working, and I don't know if we'll get it in the next month or so, but we're definitely working on being able to have a different partition scheme on the master versus on some of the subscribers. So on a subscriber, you might do partitioning on the master, but have it all in one, or you might leave a further set of partitions available on the subscriber, even though you got rid of some of those on the master because you're using that as a read-only node. So we want to add some more flexibility in there, but yes, you can do multi-master in PG Edge on partition tables.
Okay. Any other questions?
Including on PG 15 for PG Edge.
Do we have a mechanism to track the progress of initial data sync in PG Edge, like how many records pending?
It's actually a great idea. I definitely want to do that, and we are working on more metrics and exposing metrics to do that. So it's a great idea. I'll be lying if we said we had it right at this moment, but that is something that we're looking to have before we go GA in early Q4. We have other metrics that are kind of like that, like lag monitoring that will show an easy metric. So we're definitely working on visibility features for doing logical replication. And one of the users asked an excellent question that no, we don't have that yet, but it's a great idea. And I have thought of that, and we will very likely add that before we go GA over the next couple months.
Yes. I think we have another question.
think
Similar
a follow-up.
to,
That question is a follow-up on that, right?
Okay,
Like I'm not,
okay,
I will look at PG stat progress copy, right? So the whole idea there is we would, you're giving a view, a system view that makes it easy to query and see that. And then on our cloud console or whatever, we would make it, it's easy to monitor. It's easy to then in whatever graphical sort of metrics tracking solution you are, it's easy to publish like a Prometheus metrics for that and put it in our dashboard or for other dashboards to do that. So I will look at PG stat progress copy. Haven't personally looked at one. I'm familiar with dozens and dozens of extensions, but that does sound like a good idea to me.
okay. Think that's it. So thank you to everybody who participated and joined us today on this webinar. Just as a follow-up, if you want to schedule a one-on-one with a Postgres expert, you can go to this link, https://meetings.hubspot.com/Gwen-Price. Or email us at expert@pgedge.com and we'll get right back to you. Also, if you don't get this down right now, don't worry. We're going to be sending a follow-up email out to everybody who attended with the slides, the replay, and these links to set up a meeting as well. So thank you all for coming, and we look forward to speaking with you soon. Have a great day.
Thank you, Essen.
Thank you. Thanks everyone for joining.